we're to get started. So I want to walk you through the agenda for today. So what we're going to do is we're going to discuss present value. So we saw this a bit last time when we were looking at the prisoner's dilemma game and looking at cooperation versus dilemma. We're going to talk about present value, really set this up as a way for individuals to evaluate how much is going to college going to be a benefit to them versus a cost. So we're going to introduce this idea of present value. We're going to do a system of future returns to college. Then we're going to look at the cost of schooling. We're going to figure out how much schooling is going to be enough, right? Because in principle, you could either say, I'm not going to go to any school whatsoever and drop out before you get your GED, or you could become a super specialist doctor where you have to go through 4 years of undergrad, 4 years of medical school, residency, intern year. Then you have a specialization, and then you have a subspecialization, and then you're 45, before you practice, right? And so these are like the two, or you could be a perpetual student where you just continue to go to school for the rest of your life. So at what point do you stop? And like, how do we think about the cost-benefit analysis there? So we look at that. And then we're gonna, if we have time, return to this idea of schooling as a signal. So in the first lecture, remember when I showed you these graphs, where what we saw was that folks who had more education earned more money, right? And then I showed you some other charts which showed you as well that those folks also had higher math scores in their high school test as well. And so some of it could be the returns to school, really they're developing new human capital at colleges and universities, and another part of it could just be signaling, which is that the high ability people, for them it's easier for them to go to college, and it's easier for an employer to know if you're a high ability person just by looking at whether you've gone to college or not. So independently of what you major in, or if you actually learn things, or if you just party the whole time, they know that innately you're a higher, quote-unquote, higher ability person, somebody for whom the cost of learning might be lower. So there could be this signaling happening too, and we're going to return to that. And then I'll circle back to this whole idea of welfare. So in the previous lecture, we looked at, the previous two lectures, we looked at competition between firms. We looked specifically at corner competition where firms are competing on quantity and they were moving simultaneously. We also looked at stack over competition, which there's a first mover advantage as well. And so we're going to circle back a little bit and talk about welfare, looking at what is the consumer surplus, what is the producer surplus, what is the social surplus. And that's going to be very relevant when we start to make normative statements about the implications of policies, right? So who are the winners and the losers from a particular policy? And I'm going to talk a little bit about the homework as well. So at the end of the lecture, we'll return the homeworks, the first homeworks. And then what I have for you too is a handout that gives you a modification of the theoretical exercise. And so the second question is really going to push you. And so what Shannon and I have done is we've put together a list of like helpful guidelines for stepping through it. Everything that you learned in this course, you can use it to apply to that question. And so at first that question might look daunting, but it's not beyond you. And what this step-by-step guide is going to do is it's going to give you the tools, it's going to show you what is it that you know that you can apply to this problem set to be able to understand it. And if you can do this, you can do research in economics, right? It's that accessible. Okay. All right, any questions before we start?
That's like a new homework that's not due this Thursday?
No, so what's going to happen is the first question of the homework that I gave you, I want you to hand that in. So this is the part of the question, hand that in on Thursday. And I'll give you an extension until next Tuesday on the second part of the theoretical exercise. And I'll give you the step-by-step guide that'll walk you through the various steps. And I think that will be helpful. So everybody clear on that? Yep. Great. All right. So let's talk about present value. So the key idea here is that $1 today is not the same as $1 tomorrow. Who in here has a $5 bill? $5 bills? You guys look cash. $5. Okay. Now, what if I said, let me hold on to this for 5 years, and then I'll give you back $5. Would you take that? Why not? But I'm giving you back the same thing that you gave to me. Why would you not take that?
Because it's worth more.
Why is it worth more right now?
Because my $5 bill.
That's a part of it, but what else can he do with this $5 bill in the next, 10 years?
Invest it.
He can invest it, right? And he can get a return. And so say, for example, he got a 3% return, right? and we just looked at that at simple interest, right? Or let's say a 10% return, right? After 1 year, what's the return on this $5 at 10% interest? 50 cents, right? And so he can earn a lot more money holding on to this and investing this than just giving that to me. And so the present value is really going to help us to understand what's the trade-off between holding on to money today versus investing it maybe tomorrow. And that's going to depend a lot on how patient you are. Thank you very much. Okay. So the key idea is that $1 today is not the same as $1 tomorrow. Let's use this example. For example, let the interest rate R be equal to 3%. Right? And suppose that it has $100. Right? How much would I have to offer Jim tomorrow in order for him to be indifferent between $100 today and a certain amount tomorrow? So how much money must I offer Jim tomorrow so that he is different between $100 today and X dollars tomorrow? Who knows what the answer is? So I say, Jim, I can give you $100 today, or I can give you a certain amount of dollars tomorrow. If Jim were to invest this $100, right, and this interest rate is a daily interest rate here. So if Jim were to invest $100 today, how much money would he have tomorrow? Exactly, right? And so, so what you're going to have is that X is going to be 100 times 1 plus 0.03, which is just $103. Right? What if we reverse this and we said, okay, how much would I need to give Jim today so that he's indifferent between receiving that certain amount of money today versus receiving $100 tomorrow? Everybody understand the question? Okay. So suppose Jim will receive $100 tomorrow. How much money do I have to offer him today so that he is different between $100 tomorrow and X dollars today? Right? So he's going to receive X dollars today, right? So this is today. If he receives X dollars, this X dollars is going to grow at what rate? Say that again? 3%. So we're going to have X times 1 plus 0.03 must be equal to what tomorrow? 100. Does that make sense? Does everybody see that? And so this is going to imply that x is equal to what?
97.09.
Yeah, exactly. So x is going to be equal to 100 divided by 1.23, which is going to be 97.09. It's a human calculator we got here. Good job. Operated by humans, right? Okay, good. Everybody understand what we've done so far? Okay, good. So we positioned this R as the interest rate, but we can also think about R as being what's called the discount rate. I.e., the rate at which we trade consumption today for consumption tomorrow. Right? So this is consumption today, this is consumption tomorrow. All right. Now what I want to do is introduce this idea of present value, right? And we've implicitly introduced it here, which is if I know that I'm going to receive some stream of income in the future. So for example, you know that after coming to Clemson, you're going to get a certain wage in every subsequent period, right? How much do I value that stream of income today? Does everybody understand that concept? Let's go with the definition. So we're going to define the present value in the following way. The present value is going to be the value today of the stream of future payments and costs. Right? So for example, if in T years you will receive a payment X, then the present value, so whenever I use PV, PV is just the present value. Present value of X is just present value of X in T years. It's just going to be X over 1 plus R raised to the power of T. So what we saw up here, so in this example, we said, well, what's the present value of $100 tomorrow, right? So Jim is going to receive $100 tomorrow. And in order to find that, what we said was we have to take that $100 and we have to discount it by 1. We have to discount it by 1 plus the interest rate. And in the same way, if this $100 were T periods in the future, every future period, so if we had this PV here, every period in the future, if we invested this amount of money, we would get a return of 1 plus R, right? And so if we do that for T periods, this 1 plus R to the T, that's divided through the X is going to completely disappear. Right, so if we took this present value and we invested this for T periods at the interest rate 1 plus R, what do we get? So the question is, if we took this value, X over 1 plus R raised to the power of T, today, and we invested this for T periods, right? What would be the return? every subsequent period, we would grow that by a factor of 1 plus r, right? And so over 10 periods, we'd grow that by a factor of 1 plus r to the t. And so this would actually end up being x. 10 periods from now, this present value would be x. So you see the relationship between the present value is just discounting this future stream of income. Does everyone understand that concept?
So say, are you saying like by taking your present value, putting it in repeatedly like each year or so, by the end you're going to have the future value that you wish to attain back then?
Exactly. Exactly. Right? Because the future value is going to be x in t periods, and we're saying how much do I value that in the present? So if instead of it being immediately helpful for us to use this example of gym for 2 periods, right? So let's use the example of.
Can I ask you something first? So, on the today, so you have x times 1 plus the rate,
Right.
and then you got tomorrow $100. You don't understand why you have. Today you have $100, and tomorrow you have $100.
Okay. So let's return back to the question. So the question is, Jim is going to receive $100 tomorrow. How much would he have to receive today to be indifferent between that amount today and $100 tomorrow? Right? So let's call that amount x. If Jim were to invest x into a savings account, right? Tomorrow, that x would become x times 1 plus 0.03.
So use the rate.
Right? And so this is, if we were to give Jim x, and he invested it, tomorrow he would have x times 1 plus 103. And we need to set that equal to $100. And so if we gave Jim the x that satisfied this relationship, Jim would be indifferent between x today and $100 tomorrow. Because if I gave Jim x today, by tomorrow Jim would have $100. Does that make sense? Any other questions before I do this example here? So let's say, example, what's the present value of $100 to Jim if t equals 2, right? So we know that at t equals 2, Jim is going to get $100, right? And we're going to give him x in period 1. We're going to give him x in period 0. By period 1, x is going to go to x times 0.03, right? So this is how much Jim has at t equals 1. And then what he has at t equals 1 is going to grow again by 1 plus 0.3, right? This is how much Jim will have at t equals 2. Right? And so that implies that x is just going to be 100 over 1 plus 0.3 squared.
Just these two, right?
That's exactly right. That's exactly right. So the further you are in the future, the more the present value is going to be discounted, right? Because you have more periods with which you can invest that same amount of money to realize that return. So that's the way to think about it. Are there any questions before I move on from this? Who understands this? Just raise your hands. Okay. Now, so far what we've done is we've just looked at a single payment. What we've said is that Jim is going to get a payment of X some period T into the future. But what if Jim is going to get a constant stream of payments where he gets X each period? What's the present value of that full stream, right? How much would I have to give Jim today so that Jim is indifferent between getting this amount of money today versus getting X in every subsequent period, right? So we're going to say set to receive stream of payments x0 in time period 0, x1 in time period 1, x2 in time period 2, all the way up to xt in time period t. The question we're going to ask is, what is the present value of this stream of income? Everyone with me so far? Okay. So the present value of this stream of income, x0, x1, all the way up to xt, is just going to be the present value of x0 plus the present value of x1 plus the present value of x2 plus the present value of xt. Right? Does that make sense? So we're saying, okay, we want to know what the present value of this entire stream is. The present value of the stream is going to be the sum of the present values. Now the present value of x0, well, x0 is that's money that he's receiving today. And so the present value of that is just going to be x0. Right? What's going to be the present value of x1? He's receiving x1 in time period t equals 1. What's going to be the present value of x1? Who knows what the present value of x1 is going to be?
X1 over 1 plus r.
x1 over 1 plus r. Right? What's going to be the present value of x2? x2 over 1 plus. What time is he receiving x2? x2 is the stream that he's receiving in which period? Right. So it's what? What is 2? It's x2 over what? Where are you getting 2 from? It's going to be x2 over what? 1 plus r squared. Right? Because if in time period 0 he got x2 over 1 plus r, in time period 1 this is going to be x2 over 1 plus r squared times 1 plus r. And then in time period 2 times another 1 plus r, so it's going to be discounted by 1 plus r squared. And then so on and so forth, plus xt over 1 plus r to the t. So this is going to be the present value of this entire stream of income. Does that make sense? Any questions? Okay. So what we're going to do now is we're going to take this and use this formulation to compute what's going to be the cost of going to school, right? And here's the idea. So what are the benefits? Who can tell me what